Hello and welcome back. We are starting Unit C today, and we're going to be talking about periodic functions. This is the third trig unit that we've done, and we got through Unit capital B, and I think for some it was, but I was happy with how most of you did. Now, we're going to be doing 2 pages of notes, and you should have a packet from me. The first page should look like this one, and the second page should look like this one. So we're going to be filling those out today, and hopefully I showed you a cool video or two about the applications of periodic functions. There are a lot of applications. The Bose noise canceling headphones, and you've got sound waves, electricity, and just lots of really cool stuff. So let's get going. So first off, let's talk about what a periodic function is. So on your paper here, the first example, you can see how this guy goes up and down and up and down and up and down and up and down and up and down. It repeats itself, and I can actually take part of this graph, if I trace over it, and put it on part of another one, like a cookie cutter. We're going to be trying to find how long it takes the graph to repeat, so how long one cycle of the graph is. And it's easy to see. Here's one cycle of the graph where that pink is. It goes from 0 to 2, and I could take that and place that over on top of the graph and repeat. And that is 2 units, and that's what the period of the graph is. What's the period of this function down here? Well, if you look, you've got an S-curve, which, by the way, spoiler alert, that's what your sine graph is going to look like, and it goes up and down and up and down. And so from one cycle of the graph is from 0 to 4, so that is going to be 4 units for the period of that graph. And some people said, why isn't it 2? Because if I only went 2 units, it'd have to hump up again and hump up, and you got the humpy hump going. This way we've got the smooth S going. All right. The period of this graph, this one doesn't start at 0. It actually starts at 1. Well, you could start it at 0, but it would be harder to figure because I drew this and it looks like a kindergarten drew it. But this graph is going to repeat every 3 units. So it starts here, down here at 1, 0. That point goes up, flattens out, and goes back down. So you can see that that is one cycle of the graph, 3 units. If I traced over that, I could place it and repeat that pattern over and over and over. So the period of this function is 3 units. Domain and range, which we're going to get into a little bit later today. Domain is the span of your x's. And you can see that if I look left to right on the graph, I can figure out the domain, and it goes forever in both directions. There's x values for everything. So domain for this is all real numbers. Now, interval notation, some of you may not be familiar with, but this is called interval notation, and it means all real numbers. Range, if I look up and down on the graph, I notice the graph isn't anywhere in the lower 2 quadrants. It's not down below. There's only y values that go from 0 to 1. So the range is the set of all your y values. And so it would be from 0 to 1. You could also say y is between 0 and 1 in a combined inequality. You might be more familiar with that. But on the work for today, after you do these notes, you should be able to do the page that's on the back of it. And just to refresh your memory from Unit capital B, you multiply by pi over 180 to go to radians. They're reviewing that. And then you multiply by 180 degrees over pi to convert from radians to degrees. You're going to need to know that for the homework. Also, if I have something like cosecant of 50 degrees, they're trying to refresh your memory on how to put that stuff in the calculator, in that fancy schmancy calculator you got. Cosecant is the reciprocal of sine. So you don't use sine -1. That's wrong. That's sine inverse if you're given the angle. Or if you're looking for the angle, you would use that. Cosecant of 50 you would put in as 1 divided by the sine of 50 degrees. 1 divided by sine of 50 degrees. Same for secant. The reciprocal of secant is cosine. So you do 1 divided by cosine of your angle. Cotangent is the reciprocal of tangent, so you do 1 divided by tangent of that angle. So you'll need to know that for the homework that goes along with this one. We're going to